All right, let's look at concept 8. Determine the empirical molecular formula for a compound from mass percent and actual data. The empirical formula for a compound is the formula with the smallest whole number ratio of the elements. To determine the molecular formula of a compound, you're going to need the molar mass of that compound. So let's look at the example 1 from your SSS packet. And that says determine the empirical formulas of the following compounds. We have ethylene, which is C2H4, and that is not the least whole number ratio. We can reduce C2H4 to CH2. CH2 would be the empirical formula of that compound. Ascorbic acid, C6H8O6, again, is not the empirical formula. That would be what we consider to be a molecular formula. The empirical formula for ascorbic acid is C3H4O3. 6, 8, and 6 in ascorbic acid are all divisible by 2. So that's how you would get your 3, 4, and 3. Now let's look at naphthalene. Naphthalene is C10H8. And if you were to reduce that to the least whole number ratio, you would get C5H4. Now, C2, CH2, C3H4O3, and C5H4 cannot be reduced any further, so those are your empirical formulas. Now let's do a math problem that actually has you determine the empirical formula. So let's look at example number 2. It says that the hydrocarbon used in the manufacture of foam plastics is called styrene. Analysis of styrene indicates the compound is 92.25% carbon and 7.75% hydrogen and has a molar mass of 104 grams per mole. Determine the molecular formula for styrene. The first thing we need to do in this is we need to first determine the number of moles of each element in the compound. So, since we're giving percents, we're going to assume that we have a 100-gram sample. So those percents will go away and they will actually be turned into masses. So first, let's look at carbon and hydrogen separately. So, we're going to need the periodic table with our masses. So let's look at carbon. We have 92.25 grams of carbon. And we know that we need to convert that to moles. So we know that 1 mole of carbon has 12.01 grams of carbon. When we type that into our calculator, we do 92.25 divided by 12.01, and we get 7.68 moles of carbon. Let's do the same thing for hydrogen. We started off with 7.75 grams of hydrogen. We need to multiply that by the number of 1 mole of hydrogen, which has 1.00797 grams of hydrogen. And when we type that into our calculator, we get 7.69 moles of hydrogen. Remember, these values, your mole values, need to be calculated to 3 significant figures. This is only the first part of a 4-part process, so let's keep going. Next, what we're going to have to do is we are going to have to divide the smallest number of moles to determine the mole ratio of the elements in the compound. So let's look at carbon and hydrogen again separately. For carbon, when we looked at the previous slide, we had 7.68 moles of carbon and we had 7.69 moles of hydrogen. So what we're going to do is divide the moles of carbon by the moles of carbon. That is the least whole number ratio. When we do that, we get 1 carbon atom. When we do hydrogen from the previous slide, we calculated 7.69 moles of hydrogen from the mass that we were given, and we're going to divide that by the least number of moles, which was the moles of carbon. So when we do that and we round, again, we get about 1 mole of hydrogen. So our empirical formula for styrene is CH. 1 carbon, 1 hydrogen. When we look at our question now, this is not the answer to our question. Our question asked us to determine the molecular formula for styrene. So we have to take this one step further. So how do we determine the molecular formula for styrene? Well, first thing we need to do is we need to determine the empirical formula mass. Remember, this is concept 4. So we know what our empirical formula is. It's CH. So we need to take the 1 carbon times the mass of carbon, and that gives us 12.01 grams. Then we need to take hydrogen, and that's 1 hydrogen times the mass of hydrogen, and we get 1.00797 grams. Then, like we've done all the way up to this point, we're going to add all these values together. So our molar mass of the empirical formula is 13.02 grams per mole. Now what we're going to do is we're going to determine the ratio of the molecular formula mass and the empirical formula. So we're going to look at the molar mass and the empirical mass, and we're going to divide the molar mass by the empirical mass. So what does that look like? Our molar mass based on the problem is 104 grams per mole. Our empirical mass that we just determined was 13.02 grams per mole. When we divide those, we get a number that is 7.9877. We need whole numbers. 7.9877 is close enough that we can round it to 8. Now, if you were given an answer at this step where your molar mass and empirical mass ratio was like 1.5, you would need to make that a whole number. So you would need to make that 3. If it's not close enough to round by using rounding rules, you're going to have to multiply your ratio by a number to get it close enough that you can round. You'll see some of those in your practice problems. So now, the molecular formula for styrene is C8H8, and that is the answer to your question. Determine the molecular formula for styrene, C8H8. Now look at your SSS packet and complete the following problems.